Now, if we talk about if something is not neutral, we're going to call that an ion. An ion is an atom or a group of atoms that has a positive or negative charge because it has lost or gained electrons. Now, remember, electrons are negative. So we're going to have to think about like gaining a negative is going to make our charge more negative. Losing a negative is going to make our charge more positive. So you kind of have to think about it backwards if that helps at all. All right. So we would write the charge something like this. It is going to be the number and then the charge. So oxygen O2 negative. That means that I have gained some electrons because it got more negative. And when I say gained, I mean from that neutral standpoint. So if this oxygen was oxygen 2 negative, instead of it having 8 electrons, it would have 2 more because it gained 2 electrons. Another instance would be potassium. If I have K positive, just the positive means it's 1 positive, just like X, we just write X, not 1X. All right, so the 1 is understood. So that means if it's positive, we've lost an electron. And so when I talk about losing an electron from that neutral point, so I had 19 protons, 19 electrons. Well, now I've lost an electron to become K positive, and so I end up with 18 electrons there. So you can look at it that way. I tend to look at it as a balance between positives and negatives. You can also use something like this. So the charge of the ion is the number of protons minus the number of electrons, and that can help you calculate the charge. So protons, neutrons, and electrons for Mg2+ with a mass of 25. Well, I used the periodic table to help me find magnesium. Magnesium is number 12 on the periodic table, so it has 12 protons. To get the number of neutrons, it's going to be the mass, which is 25, minus the number of protons, which I said was 12, so that's going to give me 13 neutrons. Then if I want to know how many electrons, well, it is positive. That means I have lost 2 electrons. And so it's going to be, if it were electrically neutral, I'd have 12 protons, 12 electrons. I've lost 2 electrons from that neutral point, so I have 10 electrons for that one. So if you look back at it and recheck, I have 2 more positive things than I have negative things. So I end up with a 2 positive charge. Okay. So that's dealing with an ion. Ion gaining or losing those electrons, which are on the outside of the atom. Now, we're going to look at some different notations. How can we express different ions? How can we distinguish from one atom and a different atom? Well, we're going to use a couple of notations, and the first one we're going to look at is nuclear notation. We use nuclear notation a lot in nuclear chemistry. And we will see it there, but we'll also use it here. So in nuclear notation, you always have the number at the top, and I'm going to point here at the example. The number at the top is 14. That is your mass of that particular element. The number at the bottom is your atomic number or number of protons. And if you were to have a charge, it would be located on the right in the upper, upper superscript there. This particular one in the example that I was looking at has no charge, and so that lets us know that it is electrically neutral and our protons equal our electrons. So let's look at this one and look at the protons, neutrons, and electrons. So for this ion, I need my number of protons, and the number of protons is located in that bottom number. So this is 7 protons. Then to get the neutrons, neutrons are going to be mass minus protons. So this is going to be 14 minus 7. And so I end up with 7 neutrons. And then for my electrons, I have, it looks like a 3 negative here. So that means I have gained 3 electrons from the neutral point. So at the neutral point, I'd have 7 protons and 7 electrons. I have gained 3 more negative things. So that means I'm going to have 10 electrons in this one as well. Okay, now I have some for you to try. So if you would pause your video, try and figure out your protons, neutrons, and electrons for this one. And then you can restart and we'll go over the answers. Okay, for this first one here with nickel, we end up with 28 protons because that's that bottom number. We have neutrons, that is going to be 31. We say our mass minus our protons. So our mass minus our protons, and that makes it really easy when it's in nuclear notation, so we can just subtract those two, and I get 31 for my neutrons. And then my electrons, I have a 2 positive charge. That means I have lost 2 electrons, and so I end up with 26 electrons. I have 2 more positive things than negative things. Now, aluminum, I have 13 protons in aluminum, and I know that because of the atomic number there. My neutrons, I'm going to take my mass and subtract out my protons, and so I end up with 14 neutrons. And then for my electrons, I see that I have a 3 positive, so that means I've lost 3 electrons from that neutral point, from that neutral point. So at the neutral point, I would have 13 protons, 13 electrons. I've lost 3 negative things, so that means I'm going to end up with 10 electrons on that one. So I end up with a 3 positive charge, 3 more positive things than negative things. The last one is selenium. Selenium has 34 protons, and I know that because of this number right here. It is going to end up with 45 neutrons because I subtract 34 from 79 to give me that 45. And then my electrons, I have a 2 negative charge. That means I have gained 2 electrons from that neutral point. 34 protons, 34 electrons would be neutral, and I have gained 2 electrons. And so that is going to be 36 electrons. All right, my next question is kind of the flip of this question. And I ask you to write the complete symbol for the ion with these subatomic particles. Go ahead and pause the video, see if you can figure it out, and then come back and play, and I'll go over the answer. Okay, so we have to figure out what element this is, and what identifies the element is the number of protons. So I'm going to look at number 21 on the periodic table, and on the periodic table, number 21 is scandium. Scandium has 21 protons, so I can go ahead and fill that in. The number that goes up at the top is going to be the mass, and the mass is the 2 subatomic particles, or are the 2 subatomic particles added together because those are the 2 things that have mass. So 21 plus 24 gives me a 45. So I'd have 45 up there. And then I have to deal with the charge. I have to find the charge of this ion. So I'm going to compare my positive and negative things. I think this way is pretty easy. So which do I have more of, positives or negatives? Well, we have more positives. How many more positives? 3. And so that would be the answer to that question of writing the complete symbol for the ion with these subatomic particles. There is one more notation, and that notation is called hyphen notation. It has a hyphen in it. So hyphen notation what you're going to do for that one is you have the element name and then a hyphen and then its mass. And it's important to remember that it's the mass that comes after the hyphen, which are your protons plus your neutrons. You would have to use a periodic table to figure out the protons, neutrons, and electrons. And if we just look at my example here with calcium, calcium on the periodic table is number 20. So we know it has 20 protons. This is its mass. So mass minus protons would give me my neutrons. And so that's 40 minus my 20 protons. So I end up with 20 neutrons. And then in hyphen notation, there is no space for a charge. So we have to assume that they are electrically neutral, which means my protons would equal my electrons. So I got 20 electrons for that one. So real important with hyphen notation to remember that the number after the hyphen is the atom's mass. Okay, so we talked about ions, and that is when an atom has gained or lost electrons. There is another term you need to know, and unfortunately it starts with the same letter. So it's not an ion, which again has a charge because it's lost or gained electrons. It's called an isotope. Isotopes are atoms of the same element that have different number of neutrons. So they're going to have the same number of protons, but different number of neutrons, and that will result in a different atomic mass. So the mass is going to be different in isotopes, but they will be the same element. All right, so there are a few isotopes that you probably already know. Well, there's at least one, and that's probably carbon. So if I just look at the isotopes of carbon, we have, I'm going to talk about two, carbon-12 and carbon-14. Carbon-12, carbon, if it's carbon, has 6 protons, and so carbon-12 has 6 neutrons. This is a stable form of the element. Carbon-14 has 6 protons, but it has 8 neutrons. And so that causes its nucleus to be unstable. And that is what causes it to be radioactive, and we can use it in carbon dating. Now, to look at this in nuclear notation, carbon-6-12. So that's carbon-12. And this would be an isotope of carbon, carbon-14. So notice they're going to be the same element. They have the same number of protons. It's the mass that's different, and the reason is because they have different number of neutrons. Hydrogen also has isotopes. Lots of elements have lots of different isotopes. Hydrogen-1, all hydrogens have 1 proton, but hydrogen-1 is its mass, so it actually has no neutrons, and that by far is the most common form of hydrogen. Okay, so that's a little bit about atomic structure and the different notations so you can figure out protons, neutrons, and electrons of any atom.